Hey, 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 we're back at it. This is the Wolken Way. We are doing P6 today, which is a lesson on rational expressions. Another good foundational lesson for pre-calculus. You have to simplify complex fractions and know when you're adding, multiplying, what you can cancel and what you can't. Today is on a note sheet. I mean, not on a note sheet, just on a blank sheet of paper. So you can either get a blank sheet of paper or you can use notebook paper. In math, we work down, so I have folded this paper in half because I like to give myself room to work down. So I'm just going to write on this and then tape it into the notebook. So again, like I told you guys, this was P6. These are our first handwritten notes. This is rational expressions. And like I said before, a pretty pivotal lesson. Like, you have to be able to do this to be successful in this class. So if you ever need more practice, come see me or just look in your book. So example 1 is going to say simplify and state the excluded domain. So the problem that we're asked to work with is going to be x squared minus 1 all over x squared plus 2x plus 1. So there's just a couple of things I want to make sure that's clear on this right here. I'm trying to focus a little more. Hold on. I don't know if that's any better. Anywho, this part right here that says state the excluded domain, what that means is that the values of x that make the denominator 0. So we cannot divide by 0 in math. It's like the number one rule. You can't put something into 0 groups or in groups of 0 people. So that's the excluded values or the excluded domain. So this is the values of x that make the denominator 0. And here is the big thing. I'm putting it as an asterisk. This is at any point in the problem. It is not just your final answer. And one time a student showed me this. No, numerator over that, you can't have 0 in the denominator, but it's okay to have 0 in the numerator. So this is not good and this is just fine. So you don't need to exclude values when it makes 0 in the numerator. It's only when it's in the denominator. Okay, so yesterday's lesson was on factoring. So how many terms? We have 2, no GCF, so perfect squares. It's going to be x plus 1 times x minus 1. In the denominator, we have a trinomial, so we can t-chart. You'll see that you get pretty fast at these. X and x, 1 and 1, x and 1x add up to make 2x. So it's going to be x plus 1 times x plus 1. Do we have any common factors? Yes. This whole quantity that's being multiplied and this whole quantity can reduce, and so then I get x minus 1 over x plus 1. You cannot cancel out these x's because this x in its relationship to 1 is subtraction, not multiplication. And same thing here, this x's relationship to its other value is a sum, so you cannot cancel that. So this is our final answer right there, but we do have to state the excluded domain. So look at your denominator, and I like to go here, what value of x will make this denominator 0. And it's just so nice that both these factors are the same because the only value of x will be -1. So if it's -1, -1 plus 1 is 0. That'll make division by 0, and we can't have that. So there we go. Okay, example 2, moving right along, taking it up just a notch. We are going to multiply, simplify, and state the excluded domain. So for this particular problem right here, we have x plus 3 all over x squared minus 4 times x squared minus x minus 6 all over x squared plus 6x plus 9. So the directions say multiply, simplify, and state the excluded domain. Here's the thing. It's going to be easier for you to simplify first. What I mean by that is we're going to factor everything first. So this has two terms. They're not perfect squares, so it's prime. So I have x plus 3. I am putting parentheses around it because I'm going to cancel in a minute. X squared minus 4 is a difference of perfect squares, which is factorable as opposed to a sum of squares, which is not. And then I have my two T-chart problems. So off to the side somewhere you can do your work for it, but if you're getting good at them and you can do them in your head, then you would see that it would be x minus 3 and x plus 2. And then this one has also got 3 terms, so I have to T-chart that. And I get x plus 3 times x plus 3. So now, because I'm multiplying between common terms or common factors, I can cancel. So x plus 3 and x plus 3, even though they're not under the same fraction, I could rewrite them as the same fraction because they're all being multiplied, but that would just take more time. The x plus 2's cancel, and I am left with x minus 3 all over x minus 2 times x plus 3. I didn't put the parentheses around the numerator because fractions actually are grouping symbols. That fraction bar right there says group the numerator, group the denominator. You can put them there if you want because erring on the side of caution is always better than not. Now, I can't cancel out x's, I can't reduce 3's because these are not common factors, those are common terms, and you can't do that in math. But now what do I need to do is my excluded domain. What can't x equal? So it's very, very easy to look and go, oh, it can't equal 2 and it can't equal -3. But you got to stop yourself because if at any point it makes the denominator 0, it has to be excluded. So right here we canceled out x plus 2, but if I plug in -2, even to the original problem, what's -2 squared? 4. 4 minus 4 would be 0. So -2 also has to be excluded from this. Okay, example 3 is going to be to divide, simplify, and state the excluded domain. So dividing with fractions is copy dot flip. So we are going to be dividing x squared minus 2x plus 1 all over x cubed plus x divided by x squared plus x minus 2 all over 3x squared plus 3. So dividing fractions, easy as pie, just flip the second and multiply. There's the little rhyme to help you out there. So what we need to do is we need to flip the second fraction. So here's my non-mathematical symbol that I'm flipping this fraction and change that to multiplication. I'm going to save myself some time because once I get it into multiplication, I'm going to factor, so I'm just going to do that now. So we have the T-chart. It's going to be -1 and -1. And then in the bottom, there's an x in common. So it's going to be x squared plus 1. It's always hard for students to say, where'd you get this 1 from? Remember, when I reverse the procedure, it has to show up. I can't just be x cubed. It needs to be x cubed plus x. So you can always just do this, like once you see what they have in common, do that little division and you can see x cubed divided by x is x squared and x divided by x is 1. And then I'm multiplying over here, and remember I'm flipping this, so this denominator becomes the numerator, and then the numerator becomes the denominator. So x and x plus 2 minus 1. Now that I have some common factors, some in the numerator, some in the denominator, I can reduce them. And then what you want to be careful of is making sure that you don't forget little coefficients on one side or the other. So this is going to be 3 times x minus 1 all over x times x plus 2. If you prefer, you can write this as 3x minus 3 all over x squared plus 2x. Let me just be clear that neither one of these is more correct than the other. This one is written in factored form. This one is written in standard form. I will take either of them. You can't go reducing x's. You can't do any of that. They're both in simplified form. This one is just in standard form versus factored form. Okay, what can't x equal? So we need to go through and figure out what denominator's here. So I like to do it in the factored one. It's easier. So this one right here, x can't equal what? 0. X squared plus 1, you're like, what the heck? X squared plus 1? You can always do this. You can say, okay, what makes that 0? So you can set up math and then square root, and we get x equals plus or minus I. So this is why there is no sum of squares pattern, because it becomes imaginary. Later on, we will learn how to factor with imaginaries, but there is no excluded real number value for x squared plus 1. Then we have negative 2 and we have 1. Okay, now if this one did have 1, because it's in the denominator, we would have to flip it, but when it's in factored form, it's also x squared plus 1, which we know is imaginary, and the 3 isn't going to do anything. It has to be a variable. Why? Because this constant number, it stays 3, like it's not going to change, so that's why we don't have to look at it. Okay, moving on, we are going to stop doing the excluded domain because I think we've got the hang of that. Example 4, we are going to add. So with that problem, what are we adding? We have 3 times x plus 1 plus 5 times x minus 1. So here's the little rhyme for this one. When adding fractions that you see match the bottoms perfectly. So again, that has to do with common factors, not common terms. So put those in parentheses. Do they already have anything in common? And you might be like, oh yeah, they have an x, but that's not what I'm talking about. I'm not talking about common terms. So they don't have anything in common. So this one needs an x minus 1, and to preserve the equality in math, we have to give the numerator an x minus 1, and then in this fraction we need an x plus 1. Maybe that's a little better. Okay, so let's look at this. So we're going to have 3x minus 3 in that numerator plus 5x plus 5 all over our common denominator, which is x plus 1 times x minus 1. So then we're going to combine like terms. So combine like terms, you're supposed to combine them here. So we're going to add them, 8x, and then we have plus 2 all over x plus 1 times x minus 1. Now students will ask, oh, do you want it to write it like this? And again, I don't care which one you write it as because they're both correct and they're both simplified. One is just in factored form and one is in standard form. So that is the answer for those right there. So either one of those works. You don't need both. Okay, moving right along, example 5 is to subtract. So with this one right here, we have x all over x squared minus 10x plus 25 minus x minus 4 all over 2x minus 10. So remember what we said, match the denominators perfectly. So your first step though is going to actually put it in factored form. So up here, this one was already factored, that's why we didn't have to do that step. But when you're trying to match the denominators, it's based upon factors. So that's why you have to match the denominators perfectly. So here is what our factored denominators are, and now I need to match them perfectly. So this is an x minus 5 and x minus 5. This only has 1. So I'm going to do x minus 5, multiplying. So I need to put it in parentheses. Now this one doesn't match this one because it needs a 2. So times 2 times 2. So my common denominator is 2 times x minus 5 squared. I'm being fancy by putting it like that. You can write it the other way. This numerator is 2x minus, and this is where we're going to get tricky. So we're going to do this multiplication first because order of operations says multiplication before subtraction. So notice I'm putting it in parentheses because this fraction tells me subtract everything over here. So I get x squared, and then I have minus 9x plus 20. And then I'm going to keep simplifying. And the tricky part with these problems is making sure that you do distribute that negative to all three of those. Still have some more work to do. This is going to be negative x squared plus 11x minus 20 all over 2 times x minus 5 squared. Okay, so we're going to move on to example 6. I'm actually going to do this one on the back just so I have enough room for it. So moving over to the back side here, you can do it wherever you have space. It's a little bit longer. I just want to make sure that I'm thorough. So for this one, I'm putting 2 trickies. Again, I said at the beginning, this lesson, especially this problem right here and the next problem, are pivotal. We use them so much, so I want to make sure that you understand them. So this is called a complex fraction because there's fractions within fractions sometimes, and in math you are not simplified until you have one fraction bar. And right now I have 1, 2, 3, 4, 5 fraction bars. So how do I go from 5 to 1 to consider it simplified? So the first thing you're going to do is ignore the denominator and just get a common denominator, one fraction in the numerator. One fraction in numerator. So again, I'm ignoring the denominator temporarily. So this one has an x, this one doesn't, so it needs an x. This one has a 2, this one doesn't. So I get 2x as my common denominator. So here I am in my numerator, 2x. And it's the denominator of my numerator, which is weird. And in the numerator, 1 times 2 is 2 minus 3x. So there's my first step. Sometimes if you make that bar darker just to remind yourself that it's a fraction within a fraction. The second thing you're going to do is now you're going to ignore the numerator and do one fraction in the denominator. Now there is a really cool way to do this. It's in your textbook. This is the way you learned in Algebra 2 or integrated math. So this is the way we teach it, and this is the way they do in the calculus textbook. So consistency is nice, but if you think you can handle something a little different, you might want to check out piece 6 of your textbook. So this one needs a 4, and this one needs an x. So we get 4 plus 3x over 4x. So I have a single fraction in my numerator, single fraction in my denominator, and then next I need to copy dot flip because all fractions are really multiplication. Sorry, all fractions are really division, which you can convert to multiplication. So copy dot flip. So you always copy the first, always the numerator, and then you dot your division, or in this case it's your fraction bar, and then you need to flip this fraction right here. So we get, oh, that should be a 4x. 4x all over 4 plus 3x. So what do you do at this point? At this point you need to reduce. So you're looking for common factors. So right away these are binomials because they're separated by pluses and minuses. So I'm grouping those together, but these are all common. These are all factors right here. So 2 goes into 2 once and 2 goes into 4 twice, and then x and x reduce because x divided by x is 1. So I get 2 times 2 minus 3x all over 4 plus 3x. And that can also be rewritten as 4 minus 6x all over 4 plus 3x. Again, you cannot reduce any of this. This is as simplified as I can go because these are common terms, not common factors. So the step 4 in that was just to simplify where you could. So example 7 is going to be something pretty similar to that, just takes it up a little bit. I would definitely press pause and see if you can do example 7 on your own. But if not, that's okay because I will be showing that in the video. So this one right here is going to be 1 over x plus 7 minus 1 over x all over a big 7. So hints. First of all, it's always easier if you make it two fractions. So write 7 as a rational number or a ratio number, so 7 over 1. And then what were our steps? Ignore that, get a common denominator, and combine this fraction in the numerator. So this needs an x, so the numerator is going to get it, and this needs an x plus 7. So what I end up with is x, so let me do the denominator first, x times x plus 7, and then I end up with x minus, and then it's going to be x plus 7. Now be careful because you're subtracting this entire fraction, so that would be x minus 7 all over x times x plus 7, which would be cancel, cancel. I'm just ending up with, did I miss my 7? Whoops, did you see that? What I haven't done yet is I didn't copy dot flip this right here. You're probably wondering where that is. So this would be copy dot flip, that would be 1 over 7. So then when I come to this one, it should be a 7x. I was wondering where that went. So I end up with negative 7 all over 7x times x plus 7. And what you can see is that these are common factors. Cancel, cancel. So I get negative 1 all over x times x plus 7. And it's okay for you to leave the negative up there, but I'm just going to tell you textbooks and mathematicians like to put it right alongside that fraction bar. So any of those are fine with me. Moving right along now to example 8. We have 2 more, so example 8 and example 9. So example 8 is going to have us do the exact same thing that we just did, but we're going to combine two concepts. We're going to combine radicals, and we are going to combine the other complex fractions. So this is what you're going to do. you are going to do the same thing. It's the same thing over and over again. So this one doesn't have a denominator, so let's give it one. So this one needs to be root x times root x. And this one just has a 1, so it's going to stay the same. So what this ends up being, if I change this, is it's going to be what square root x times square root x. We already did that. Square root x times square root x means we can combine it under 1 under x squared, and that is going to undo it. So I'm going to get x, and then over here I didn't have to do anything, so it's going to be plus 1, and then it's going to be over root x. And then remember, we have to make this over 1 and copy dot flip that. So times 1 over x. So what I have there is x plus 1 times 1, which is 1, and then I have x root x. But again, no square roots in denominators, so I need to rationalize. So I'm going to do root x and root x, and because I'm multiplying by something that already has two quantities, I'm going to put it in parentheses. So I get x root x plus root x, and then square root x times square root x is just x, but there's already a single x there, so that should be x squared. Okay, last problem. Woohoo! This one is going to be a tricky. So sometimes in this class we practice a skill that we're either going to use later in our class or we're going to use it in calculus. So we're going to practice the basic skill right now and then apply it later on. So that's what this problem is. We're just practicing a basic skill and we will use it later on in this class. So this is going to say rationalize the, and you were expecting me to say denominator, but it's actually numerator. So that's different for you, but it's very similar to rationalizing the denominator. So here is the problem right here. The square root of x plus 3 minus square root x over 3. So with this right here, obviously the denominator is not irrational. It's the numerator that's irrational, and we need to rationalize it. You're asking me, like, why would I want to do that? Again, application is later on. So this part right here, how do we rationalize? Well, we need to multiply by the conjugate. So if you recall, the conjugate is where you keep the same terms, you just change the sign in between them. But to preserve equality, I do have to put this in the denominator as well, because then I'm just multiplying this fraction by 1, which means it stays at its same value. Okay, so now here we go. How do we do this? So square root x plus 3 times square root x plus 3. That's just x plus 3 squared and then square rooting it. So that just ends up being x plus 3. So again, I'm doing this times this, and then this times this times this, and this times this. But we already learned that when you multiply by conjugates, your middle term cancels out. So why are we going to do that middle math? If you need it for processing, go for it. But for those of you who don't, you know that if you have a plus b times a minus b, that's the same thing as a squared minus b squared. So it's the reverse of difference of squares. So since I have a plus b, well, it's actually a minus b and then a plus b, I know that if I just square this and then I square that, then I will have it. Now here's the tricky part of this right here. Your gut is going to tell you that in the denominator to multiply that out, but you are going to leave it in factored form anytime you're asked to rationalize the numerator. The reason why you're going to do that is because if you look at these problems, they're rigged so that what happens here is we have a common factor of 3. And you may not see it if you multiply that through, because you'll multiply it and then you'll have to factor it right back out. So I know there's going to be radicals left in this problem right here. in the denominator, and that's fine because we were asked to make sure that the numerator was rational, not the denominator. Alrighty. So that is the end of the lesson. Sometimes you might hear my family and or my dogs, which are also members of my family, in the background because I'm at home when I do these. So don't worry about that too much, and if it's too loud, just let me know and I'll try and find a quieter place. Anywho, that's it for today.